It's homework time! Yes, happy. Homework time is here yet again. Let's start out by jotting a name down at the top of the paper. I'll write my name, you write yours. And then today's date, shall we? Yes, we shall. Today, I will write today. You write the actual date, where and when you are in this wonderful world of ours. Our instructions: compare the pairs of fractions by reasoning about the size of the units. Use greater than, less than, or equal. And if you notice, we can look at all four of these at once. It's one of something and one of something, two of something, two of something, two of something, two of something, 5 and 5. Okay, so they're matched in that way. They all have the same numerators. They all have the same top numbers. And so all we're thinking about then is the denominators. Okay? So look at this first one, 1/3 compared to 1/6. Okay, so picture that birthday cake in your mind. Let's make it a rectangular cake. And it's cut into 3 big pieces. And then you cut it down the middle, as we've done decomposing fractions. And now you have 6 pieces. Obviously one of those thirds is going to be twice as large, in fact, as one of those 6. So having 1/3 of the cake is actually having more than having 1/6. And so this would be greater than. And the reason that this is difficult is it's kind of counterintuitive because we're so used to bigger numbers are bigger. And so you're like, hey, 6 is more than 3. What you talking about, crazy man? But 1/3 is actually more than a 1/6. And if it is all helpful, you don't need to do this on your homework, but we'll just draw out. Hey, if you say, it works particularly well with this one. It doesn't work with all of them this well. So there's thirds, right? So there's the third. And then now you can see a 6 is a much smaller piece. So same thing here, 2 halves. Okay, or 2/3. Okay, so we have 2 in either case. 2 halves, we actually know that's the whole cake. You just cut the cake in half and you have both halves, you have the whole cake. If you cut it into thirds and you have 2 of those thirds, there's still a third left in the cake pan. So 2 halves is obviously more than 2/3. And if you find this at all confusing, you can draw out for all of these, really. But I won't do that to you unless you really want to. And here again, we're comparing 4ths and 6ths. Now, based on what we've learned, we can probably do this right in our head and know, okay, it's the opposite day thing, that 4 is now bigger than 6 all of a sudden. But it makes sense. If you cut that cake into 4 slices, 2 of those slices is going to be more than if you cut it into 6 slices. Those are going to be smaller slices, and you had 2 of those. So 4ths are greater than 6. So 2/4 is greater than 2/6. And lastly, same thing here. We have 5/8 compared to 5/10. Obviously, cutting it into 10 pieces, those are going to be smaller pieces of cake. So 5/8, those are bigger pieces of cake. So 5 bigger pieces compared to 5 smaller pieces. Obviously, 5 bigger pieces is greater than. Huh. Let's go on. Ho ho! In number 2, they actually did the most difficult one for us. Thank you, freakas. Compare by reasoning about the following pairs of fractions with the same or related numerators. Okay, what does that mean? Well, right there. We're going to use greater than, less than, or equal to. That's what we're doing. So in this case, though, either the numerators are the same. If you look at A, 3/6, 3/7. You look at C, 3/11, 3/13. Or the related numerators, because if you look at B, if you look at B, take a look here, that 2 is half of 4, and here 5 is half of 10. Okay, so that's what they mean by related. And we'll explain our thinking using words, pictures, or numbers. Thank you again for doing 2B for us. So let's look at that first. Now, because this is the trickiest one, so it's a good one to look at. So 2/5 they're saying is less than 4/9. Why? Okay, well, look, 9ths are pretty close to 10ths, right? So if we were to compare 2/5 with 4/10 instead of 4/9, those would actually be equal, right? And here's the picture to prove it. Okay, so 4/10 is going to be less because 4/9, less rather than 4/9 because tenths are smaller than ninths. So think about it. These are right here. We'll look at the 2/5 equals 4/10. Those are equal. Okay? So 4/10 is less than 4/9 because tenths are smaller than ninths. So that means then, 4/9 is actually greater than 2/5 because 4/10 would be equal. I know, that's a tricky logic to follow. I'm glad they did that one for us. All right, but here's an easier one. 3/6 compared to 3/7. We just did a bunch like this, right? All A, B, C, D up there in number 1. So 6, we know, are going to be bigger pieces. So 3 bigger pieces of cake compared to 3 slightly smaller pieces of cake. Obviously, the 3 bigger pieces of cake are more. And so we can say that 6 are larger than 7ths. So 3/6 is greater than 3/7. And you could write that out in words if you want as well, but it's not necessary. And again, look at C. We have the same phenomenon here. We have 3/11 compared to 3/13. And don't even try to draw that mess out. So 11ths, we know, you're cutting the cake into fewer pieces. They're going to be bigger pieces. So 3 bigger pieces compared to 3 smaller pieces. So obviously 3 bigger pieces is more than 3 slightly smaller pieces. And we're going to say the same thing here. We're going to say 11ths. So you write 11 and put the THS on it. 11ths are larger than 13ths. So 3/11 is more than 3 the smaller pieces, 3/13. All right, and now in this last one we have one that's more like B, so it's a little trickier. But when we look at 5/7 and we look at 10/13, something should occur to you here. That if we were to take, and I'll write it up here, 5/7. I noticed the relationship between 5 and 10 is times 2, and 7, well, times 2 is 14, but not 13. So if we were to think of it this way, we would find that 5/7 equals 10/14. Okay, so this is just like the one up above, okay, just different numbers. So if 5/7, here, we'll just write it out nice and fresh so you can see it. If 5/7 equals 10/14, okay, if those are equal, right, and 13ths are ever so slightly larger pieces than 14ths, that means that 10/13 is larger than 5/7. You see that? In fact, if you to make it a little clearer, if you just kind of keep going, if we ticked it down, like what if we went down to 10/11, 10/12, 10/10? Well, that's the whole cake, right? So you see, as I keep going with that denominator from 14ths, which is the equality, 13ths, 12ths, 11ths. When I get to 10/10, that's the whole cake. That's definitely more than 5 out of 7 pieces, right? So you see, as we go numerically down from the 14ths, which is the equality, the pieces of cake are getting slightly larger. And so we're going away from that equality with the 10 pieces of cake becoming the larger one. So 5/7 indeed is less than. Okay, and we could draw similar pictures here, but honestly, you're not going to be able to draw a picture, and neither would I, that really demonstrates the difference between a 13th and a 14th. So let's not bother. And so, for finishing out, we can use pictures or numbers. So we started using numbers here. We can say that simply because 5/7 equals 10/14, then 5/7 is less than 10/13. Again, I'm going to use the word because 13ths are greater than 14ths. All right, that explains it. These are tricky, right? But let's go on and do some more, just for fun. All right, now in number 3, we're to draw 2 tape diagrams to model each pair of the following fractions with related denominators and use greater than, less than, or equal to compare. What I'm going to do is I'm actually going to draw, we have to draw tape diagrams, which are different from area models, and you'll see why we need to do that. So, best you can, draw 2 rectangles, and I'm going to make them pretty big because we have to make 12ths in one of them, or long rather, because these are tapes. So we need 2 good long rectangles. This, I'll be honest with you, is going to be a bit of a pain to draw the 12ths. So we'll just have to deal. 3/4 is easy though, right? So we know with fourths we have a little way of doing it. If you split it in half and split the halves in half, okay? And I'm not going to shade these in. I'm just going to mark like here's 3/4 because it's just too big of an area to shade in. But what I can do now to make the 12ths is I can copy these lines from up above, all right? And you could probably do the same. See, so now just to make this a little bit more doable, and my sections are far from perfect, as you see. So that's fourths. So if I, so in order to make 12ths, each of these has to be divided into 3 partitions. So if I draw 2 lines within each of those fourths, I will end up with 12ths, and I think that's the easiest way of drawing 12ths rather than counting off 11 lines within the rectangle and trying to get them somewhat evenly spaced. Okay, so there's 3/4, and so now 1, 2, 3, 4, 5, 6, 7 12ths would be right here. I'm going to label that on the top side so we can more easily compare them. So 8, 9, 10, 11, 12. Oh, I did it right. Look at that. And so now it's easy to see that 3/4 is definitely greater than. Another thing we can do here, and I'm just giving you a little bit of a sneak preview here. If we were to think of 3/4, well, how many 12ths is that? Well, we've done this. Find the equivalent fraction. What's the relating factor between 4 and 12? It's times 3. And so if we do 3/4 times 3/3, we find that the equivalent is 9/12, and 9/12 is obviously greater than 7/12. So you can do this numerically as well. I just want to show you don't have to draw for the rest of your life these tape diagrams. So 3/4, of course, is greater than. Let's go peek round the corner at 3B. And in 3B and C here, we're doing more of the same. Taking a quick look, though, we see, okay, B looks reasonable, like we can do that. C, though, now we're dealing with mixed numbers, y'all. All right, so let's start off with B. And because we're only going out to eighths, this is not quite as painful here. So 2/4 is going to be easy to do. And then to draw 1/8 below that will also be pretty straightforward. So this one's easy, I could say. All right, so 2/4, so we can make fourths, right? Zoop. We just did this, so we know how to make fourths. All right, and there is 2/4 in the middle. And to do eighths, we can actually, and make sure your rectangles are, best you can, the same size and shape. I can actually just copy those lines from the fourths, right? Because this is what we did up top. But this time, in order to go from fourths to eighths, it's a factor of 2, so I just need to split each of these fourths in half. And then I will have 8 parts. And then it's very easy to see. Here's 1/8. Very easy to see that 2/4 is, yes, much more than 1/8. If you were eating cake, you would want 1/8. 2/4 of the cake would make you sick, and that's obviously half the cake, right? All right, so now let's get on to the bad boy here. Let's do it like this. I'm going to use all this space up here as well. So we want to draw 1 4/10. Ooh, man, they killing us. All right, so let's draw a nice long one. Yeah, that should do. This is tricky. So if my Eureka friends are out there listening, I'd say like, this is kind of overkill for drawing tape diagrams. Doing this mathematically, absolutely perfectly appropriate, but doing this in a tape diagram is just like, it's too much. All right, there I had my say. So now, when we look at this, how are we going to draw 1 4/10 in a tape diagram? Well, we need to demarcate 1 somewhere, right? And then 4/10 as well, and then we'll do the same with 1 3/5. One way to do this, and I'm not sure how your teacher would feel about it, I would be fine with it, is to say, well, they both have 1 whole, so I can kind of just set that aside, right? And just look at 4/10 compared to 3/5 because I know they both have 1 whole. So let's do it that way because that is what makes sense to me. And let's draw the fifths first. So I'm going to do it on the bottom here. So we're going to draw 3/5. So I need to draw 4 lines in here equally spaced to make fifths. So 1, 2, 3, 4 lines makes 5. Hey, that's pretty good, I have to say. And now I can see, oh, if I copy these lines up top here, I'll easily be able to make tenths. Okay, so I'll copy those 4 lines that I just drew and then bisect each of those in order to make tenths. Okay, so where's 3/5 going to be? 1, 2, 3/5 is right here. And where's 4/10 going to be? 1, 2, 3, 4/10, right? And we know that they both have, and I'll just indicate it here, like they both have a 1 whole going on there as well, but you know, those are equal, so we don't really need to draw them. And now we can see that 1 4/10 is less than, I'll make that look less like a 6 and more like a 0, is less than 1 3/5. And again, like the other one I showed you, if you converted the fifths into tenths, it'd be a factor of 2, right? So it'd be 6/10 compared to 4/10. You could see that 4/10 is less than 6/10. Very good. Let's go on to number 4. And number 4 here is essentially the same thing. We're just drawing number lines instead of tape diagrams. So we're kind of stepping it back a pace there. So let me just draw out 4 nifty little number lines to get us started. You notice all the fractions are proper fractions. You notice that? So we won't have anything greater than a value of 1 to reckon with. And we know our number lines always have those nifty little arrows at the end. So let's draw those in. Kind of do it production work style here with the homework. Just draw all the number lines first so we know we need them. And we know on each of these we're going to have a start point and an end point. And again, they're all proper fractions. So what will our starting point and ending point be on all 4 of these? Well, all of these numbers fall between, that's right, 0 and 1. They all have a value between 0 and 1. So we can just go ahead and label all of these 0 and 1 and get the pain of that over. So I told you, we're like a factory assembly line. We are the Industrial Revolution of math. All right, so now let's look at 3/4 compared to 5/8. Okay, fourths, it's the same thing as what we did in the rectangles. Just split it in half, split each of the halves in half, and there's our little friend, 1, 2, 3/4. Now to, fix that. All right. Now to draw eighths on that same number line, because that's where we draw 1 number line, not 2 separate ones, I can bisect each of the fourths, and that will give me eighths, and then count 1, 2, 3, 4, 5/8. Ah, there it is. So obviously 3/4 is closer to 1. It is greater than 5/8. And now, same thing here. On all of these, let's make a deal. Shake hands. To draw the smaller number denominator first. So let's draw the fourths first. It'll be easier that way. So 1, 2, 3/4 again, just like we had on the last one. And now to make 12ths, as we did up in one of the tape diagrams, if we take, it's a factor of 3, right? 4 times 3 is 12. So each of those fourths, if I draw 2 lines inside, I split it into 3 parts. And I should try to space them a little more evenly. But honestly, it doesn't make all that much of a difference. Because 11/12, regardless of how you do it, well, that's 12/12, so I don't even have to count out, right? 11/12 is all the way here at the end. So 11/12 is, that's right, greater than 3/4. It's closer to 1 there. Okay, now we have to deal with fifths and tenths. Still not a problem because it's a factor of 2. So we can draw 4 lines between 0 and 1 to create fifths. So 1, 2, 3, 4. There's our fifths. 1, 2, 3, 4 fifths right there. And now to make tenths, we just split each of those fifths in half. And magically, because it's a factor of 2, that's why we're partitioning them into 2 parts. And now 7/10 we're looking for. 1, 2, 3, 4, 5, 6, 7/10 is right there. And so that means 4/5. It's closer to 1. It is greater than 7/10. Now here we'll start with the thirds, okay? So let's do 2/3. So just 2 lines. We'll split this number line into thirds. 1, 2, 3 parts. There's 2/3. And again, it's a factor of 3, just like on the last one, or on up here on B. So 3 times 3 is 9. So if I put 2 lines inside each of these thirds, I'm partitioning each third into 3 parts. You see why we did stuff like this before? Because we're actually using it now. And so I know that 1 is 9/9, so 8/9 is the 9th right before it, all the way at the end there. So 8/9 is, it's close to the 1. It is greater than 2/3. All right, let's roll on like a steam engine. Whatever. Instructions on number 5 here. Compare each pair of fractions using greater than, less than, or equal to. Draw a model if you choose to. In the past they've said if you need to, but now it's if you choose to, if it delights you. Well, we won't need to on most of these, but we will perhaps on some. I think we will, yeah. All right, but this first one we definitely don't need to. If you have 1 hot dog compared to 2 hot dogs, they're both 7ths, right? So they're the same size. So 1 hot dog compared to 2 hot dogs, 1 hot dog is less than 2 hot dogs, right? All right, now we're going to look at this one. We're comparing 5/7 to 11/14. Well, you notice something about 7/14, don't you? We could draw a model for this, but I think I'd rather just do the equivalency, which is something that you spent many a lesson learning. So if I want to go from 7ths to 14ths to better compare these, well, let's think about it. It's a factor of 2, right? So if I multiply here by 2 halves, it tells me that 5/7 is equal to 10/14. And this is why, particularly on this one, I didn't want to draw a model. It would be very difficult, or nearly impossible, to draw models that clearly demonstrated that 10/14 and 11/14 is too much. But we could see from finding the equivalent fraction that 5/7, aka 10/14, is less than 11/14. Okay, so now on this one, 7/10 compared to 3/5. Honestly, I want to do the same thing on this one because, again, they're pretty close. If we compare fifths and tenths, you know how to do this. It's a factor of 2, right? That 5 times 2 is 10. So we'll do the same thing to the numerator, multiply it by 2 halves, as we did lots of times before. And that is 6/10. Yes. We could have done a number line for either of these, but I think finding the equivalencies makes it a bit clearer. So now we're really comparing 7/10 to 6/10. So obviously 7/10 is more than 6/10. And again here, yeah, I just don't want to draw a model for this one. How about you? But it didn't say we couldn't do equivalency, so we're doing it. Ha! All right, let's look at 2/3, and we're comparing it to 15ths. Well, that's a factor of, ooh, what? 3 times what is 15? Times 5, right? All right, so we'll do the same thing in the numerator to find an equivalence. So 2 times 5 is 10. So 2/3 equals, and I'll write it down here so you can see clearly, equals 10/15ths compared to 9/15ths. It's obviously more. All right. And the same idea here. We're comparing 3/4 with 9/12. And we want to go to 12ths with those fourths, right? So that's a factor of 3, right? 4 times 3 is 12. So if we multiply 3/4 times 3/3, that tells us that 3/4 is equal to 9/12. Oh, this is the first equals we've had, isn't it? So this is equals. Ah! Now, think about it. And we said as that denominator gets smaller, the pieces of the cake are actually bigger because you're cutting the cake into fewer pieces. It doesn't matter that these are improper fractions because they both have this. It's the gods. They both have the same numerator, so we're talking about 5/3 compared to 5/2, and we know that halves are bigger than thirds. So it's 5 smaller pieces compared to 5 larger pieces. So obviously 5 smaller pieces is, I hope you said less than, yes, less than 5 larger pieces, and we don't need to draw a model on that. Oh, we're almost done. All right, let's do it. And number 6, don't worry about it, it's going to be quick and easy. So basically all we're doing is comparing two fractions, same as we've been doing. So Simon claims that 4/9 is greater than 1/3. Okay, so let's actually write that mathematically. This is what Simon is saying. Simon says this. He says that 4/9 is greater than 1/3. Okay. Ted thinks that 4/9 is less than 1/3. Okay, so he's saying 4/9 is less than 1/3, and we want to find which of these is correct and support our answer with the picture. Well, let's do a number line, hey? Shall we? Sounds good? All right, so draw yourself a nice pretty little line. Put some arrows at the end. Look at these fractions. They are both proper fractions. Their values are both less than 1. They're between 0 and 1, so that'll be the ends. And you notice we have the convenience that we're talking about thirds and ninths. So let's go ahead and draw out first thirds, just as we did before. In fact, I'm going to go ahead and make these strokes a little larger and heavier so we can easily see those thirds after we trisect them. So here's 1/3, right? Okay, so now it's a factor of 3 to 9, right? 3 times 3 is 9. So if we draw two lines here, we'll create 3 partitions which within each third. So now I'm drawing ninths. And I'm making these a little smaller. Okay, so 1, 2, 3, 4/9 falls here. Okay, so we can clearly see that 4/9 is more than 1/3. So our statement, make sure you answer the question I actually asked, which is Simon is the answer. Simon is correct. Because, and all we have to do is write what we discovered, that 4/9 is greater than 1/3. All right. That's it. You did it. You completed another homework time. Great job. I'll see you again next time. It is, once again, homework time.